So I'm going to start the recording now because I do want to go over the homework assignment. I want to go over and actually do the homework assignment, not to kind of rub salt on wound, so to speak, because I think some people may not have enough time to get it done completely. Okay, but the key point of the homework assignment is not whether you get it done perfectly or whether you even get it done, is to try to get it done. Because in the process of trying to get the homework assignment done, you will encounter problems. And those problems is what is making you learn about the concepts. I can talk about concepts all day long, and you can read about the concepts all day long, or re-watch the video all day long, but nothing is going to sink in until you actually get into those issues, and until you actually say, okay, how come my program is not working? Why is it not working? By thinking about why your program is not working, you are, I'm hoping that will connect to the concepts that we talked about in the class. All right. Yep, go ahead.
I just have a question. If we would have the partial credit for homework assignment, when you basically got this right, but you made something wrong, which screwed the result, will you still have a partial credit for the general concept being in the correct way?
If it doesn't work, then you won't have partial credit. It has to work for certain test cases to get partial credit. Okay. In other words, it may not be you may not handle all the test cases. If you handle one test case, then you get one portion of the partial credit. Okay, it's based on the result and not based on the code in the of what you turn in.
You still allow fix it. Like last one.
Okay, so what I'll do, okay, guys, settle down because this can be important. Okay, you guys ready? Okay, so I'm going to put this into today's folder, and I'm just going to redo the entire homework assignment. So cat to parse.s, and then do the paste here, and then this will be the starting point. Okay, parse.s. And some of you may be thinking, but Tag, you have done this so many times, you're just reciting from the solution. I tell you, this is my first time doing this homework assignment too. I tend to change all my homework assignment, because remember, I do all the recording, and I have recordings of last year and recordings of the year before last. If I use the same homework assignments, you guys can just watch YouTube and not have to do your homework assignment, right? So I changed my homework assignments, and
But see, if you were that smart, you should just allow us to get away with that.
Yep, go ahead.
Just want to ask if you can place this solution after it's done on a link.
Mm-hmm.
I mean, other than watching videos to see the homework.
Well, remind me to do so. Okay, that is part of your responsibility, is to remind me to upload the files. Okay. All right. So when we look at a program like this, it is important to pay attention to details. Okay. Assembly language programming is all about details, lots and lots of details. The compiler takes care of. Okay, you guys have any questions? Okay. Now, when you write a program in C, a lot of the details are handled by the C compiler. So we are all spoiled by the C compiler because we don't have to think about things like that. But when you program in assembly, you do have to think about all the details. Now, how do we know that we have to think about all the details, like the width of a variable and stuff like that? Every time you have to choose between the available instructions, you have to pay attention to the details. Let's just say that we are talking about move, okay? MOV, the mnemonic is MOV, the move instruction. How many variants do you have? Not even considering the operands. You have at least 3 variants. Move B for moving a byte, move W for moving 16 bits, and move L for moving 32 bits. Okay? Now in the class, many times we use move L because a lot of the things that we deal with are 32-bit wide. Addresses are 32-bit wide, 32-bit integers are 32-bit wide, and so on and so forth. But it doesn't mean that we should by default pick move L. Every time you write the instructions, you have to choose: am I going to move byte, move word, or move long? Okay. Let's look at conditional branches. It's even worse. Okay, because we have all the different conditional branches, and some of these look about the same, but they're not exactly the same. We have JL for jump if less than, and then we have JB for jump if below. So when you have a conditional branch, then you have to think about, but which one is right for this program? Because if you think, oh, okay, I'm just going to try with JL, then your program will work part way in this particular case, and then it will stop working at a certain point, simply because JL pays attention to the sign bit and JB does not. Okay, so one is intended for signed numbers and the other one is intended for unsigned numbers. Now those are the things that we actually talked about when we talked about those instructions, but it didn't really quite sink in at the time because we really did not have this kind of context to say, okay, but it is actually important to select whether you should use JL or JB. So I'm just going to write the program right now, switch into the data section, and then have all my variables declared like this. Okay, CH only needs a byte, so I'll just say we'll allocate 1 byte and initialize it to 0. And here we have x dot int. I'll just give it 0 with all the different types. So we have b1.int 0, b2.int 0, and then we have power.int 0 as well. All right, but even at this point, you have to think about the memory layout of all the labels that we have defined. In other words, you kind of have to think about what exactly is ch::byte doing. I'm allocating exactly 1 byte here. Okay, so I have 1 byte allocated, and the next one is allocating 4 bytes. Right? What happens when you say move L CH into EAX?
It's going to pull the first 3.
It's going to pull the byte at CH and then plus the 3 bytes starting at X. Okay, so that means when X gets a different value, depending on what it is, move LCH into a register will not move just a lower 8-bit number. It's going to move something in addition to the byte that you intended to move. So these are all very important details. All right, so let's switch back to the text section. So we're actually starting to write the program here. .global start _start. That's my entry point of the entire program. I'll put a no op here, and start your code here is a label that you have to put in your program so that my grader script can actually access it. If you forget to do it, I will go into your code and find the right place and put it there. Okay, at no cost of your points. Yep.
I had in my start below, and I took down the B1 to 5 and initialized it.
Well, I will still have to find a point where my script needs to stop, and then I will set the correct B1 and B2 to test your program. So I will. That's why when I grade these programs, I actually have to look at every single little program. It's not like I just let the assembler do everything and I have nothing else to do. I actually have to read the programs and find out what needs to be fixed before my test script can even start to run. And sometimes I would look at my test script and it fails, and then it'll go like, oh, okay, so this person forgot to do this in the program, that person forgot to do something else. Then I have to adjust my script or fix the programs and then do the whole thing again. So that's why it takes a little bit of time. Okay, so these are not too difficult. We move 5 into B1, we move 7 into B2, and both of these are direct operands. In this case, move L is correct because B1 and B2 are 32-bit integers. Move L moves 32 bits, so we are good. Okay. And over here, we have X initialized to 0. That's outside of the loop. So we'll just go ahead and initialize X here. And then we have a loop to read in the number. Now, when you read in the number, the first part is how exactly are we going to implement something like this? Okay. Well, we did talk about the read call in class, and I translated that into the assembly version code. Okay. Basically, you have to use system surface number 3 in place of read. 0 is going to go into EBX. The address of CH goes into ECX, and then the number of bytes, which is 1, goes into EDX. So we did talk about that stuff in class. And then we'll go ahead and say, okay, while 1 begin. How you want to choose to name your labels is entirely up to you. I'm just naming my loops sequentially. So the first loop is while 1, the second one is while 2, the third one is while 3. Okay, so I'll have while 1 end here, because I know that I will need these labels, so I might as well just predefine the labels. And I also know that I have an unconditional branch here back to while 1 begin. So I'm going to put all my labels here. In other words, I'm not translating the program literally line by line. I translate the structures first, and then I go back and fill in the details within the structures. So this way I will never miss these really important points of a loop. Now that I'm done with this part, I have to say, okay, but what are we going to do to get out of the loop? Well, since this is a conjunction, that means if either condition is false, we are getting out of the loop. But that means we still have to try to read the byte in first. Okay, we'll try. So we'll go ahead and move 3 into EAX, because it's system surface number 3, and that's what EAX is specifying, is which system surface are we requesting. There are plenty. System surface number 1 means we want to get out of the program. 3 means we're reading. 4 means we're writing, and so on. And then we also have to specify what is the file descriptor. That's in EBX. We have to specify where are we reading that byte into. What is the memory location that will contain that 8-bit after we perform the read operation. That's in ECX. And then we also specify how many bytes am I trying to read, just one at a time. And then I perform the software interrupt. The software interrupt, which is the int instruction, is the mechanism. It's kind of like a call instruction, except it is not call. You don't specify where you're calling. It is a software interrupt, so that you can elevate the privileges of the system to the point where it can actually perform the file operation. But when it comes back, the privileges will also be returned to the application level. All right. So when int is returned after the int instruction, then we would have read that 1 byte in. But when you look at the C code, it is not just reading it. I'm also using the return value of read to decide whether it is time to get out of the loop or not. Now remember in the class, I said EAX indicates the number of bytes read after you read a byte. So that's what you need to check after the int $0x80 is to check whether EAX is non-zero or not, because in C code, anything that is not 0 is considered true, anything that is 0 is considered false. So what we can do here is just to do a compare long instruction, because EAX is a 32-bit quantity, so compare long would be appropriate. And we are just comparing 0 to EAX. If it is 0, JZ, we are getting out of this loop. So we go to while 1 end. Are we doing okay so far with the translation? Yes?
How do you have no input and pass that point? Because when I press enter,
Yeah.
it would have 1 character, and if I press anything else, I'll still have to press enter to pass that. So there's really no use for that.
I disagree. I can doctor a file that would test whether your program can get out because of this.
I didn't see a point, so I took it off.
Well, your assignment is to implement the code as it is described. So if you take out, or change the logic, it may or may not, work out with all the test cases anymore. Okay. Does anyone want to see how I can, create, a test case where it will encounter end of file before the end of line? It's pretty easy. Okay, so I'm digressing here a little bit here. Yes?
Really quickly, by default, like if you didn't mention L, would it be L by default? Compare
What?
L.
Compare L.
L suffix.
Okay, let's get back to the program when I get back there. Okay, so let me just kind of focus on the test file here. So the test file only needs like a number here. Now, but the editor is smart. The editor always appends an end of line at the end of the line. Okay. Hex edit. No, I don't have that. I know why. I know what I can do. It's even easier than this. I was about to use a hex editor in order to get into the file and use a hex editor to modify the file. But as it turns out, there's a much easier way to do it. And you guys know how to do it too. See, the key is to do something that you should be able to do as well, reading that part. Okay, this is what it is. Generate end of file before end of line. .c. I'm pretty sure I'm using more code than I have to be. Oh, almost forgot that one. I'll just call it gen, okay? Don't feel like typing all that stuff here. Okay. There's no end of line. The file only has 2 bytes, and there's no end of line at the end. So your program will encounter end of file before it sees end of line, because there is no end of line. Okay? But if you write the program as it is specified in the C code, it would have handled this one. Not a problem. All right, so getting back to, not this program, getting back to our .s file. Okay, so we'll continue. Your question was?
Just want to make sure, when MOV, or is the L the default suffix?
On which line?
No, I mean in general, is L a default suffix when you do not specify this?
Not necessarily. It depends on the operands too. If you say move $0% BL, then it knows, it's smart enough to know it should be using move byte. Okay, so I would always specify the width. Okay, because if I do something stupid, which I always do, if I say move B $0 and then use % EAX, the assembler is going to complain and say, hey, something is not right here. It's not consistent. That that's my second chance to fix the program. Maybe it really should have been move L. Maybe I have to change the register to an AB register. I don't know which way, the assembler doesn't know which way it should go. And that's why it complains. And that gives me, the programmer, a second chance to look at that piece of code and go like, okay, I must have mistyped something here, but which way it is supposed to be. So I'm not relying on the assembler to choose on its own. If I had used move instead of move B, then if the intention was actually move L and I picked the wrong register, then I would not have been able to catch that. Okay? So that's why you always want to specify the width of the operation whenever you can. Specify as much detail as you can. All right. So that means if I am not jumping using the JZ, that means the read operation actually read something, and that means I have to go through the second operation. So I always write down some comment after a conditional branch instruction. Unless it is really, really obvious, I always write comment after a J conditional branch instruction to remind myself what does it mean if I continue after the conditional branch instruction. That's just a habit that I picked up, because I have done a lot of assembly language programming, not only because I'm teaching this class, but also in my previous life, I have to write, firmware, software, and a lot of that stuff is actually in assembly. So I have to deal with fairly complex programs. And if I don't do this, I look at the code, I look at this code 3 days later, I would have no idea what I'm doing here. So it is very important to me to write down and say, if I'm here, this means, we just read something into CH. Doesn't have to be long, just one little line to remind yourself, what does it mean to continue execution. Okay, if we did read something into CH, now this is a typical thing, where you can say, okay, we'll just go ahead and compare 10 versus what is at location CH. I'm leaving it up to the assembler to decide, should it be compare byte or should it be compare long? But I really should not be doing it because I know that this is compare byte. Okay. And if it does equal to 0, if it does equal to 10, I have to get out of the loop. Because to stay in the loop, I need CH to be different from 10. So that means I have to use a JZ again to while 1 end. Are we doing okay so far with this program up to this point? Okay. Now, I also kind of broke one of my rules of not really testing the program, at this point. So maybe this is a good point where I can stop and test the program. I'll go ahead and go to the very last line of this program and finish it up by using a move L $1 EAX 0 into EBX and exit the program. Why do you think this is a good point to test the program? I'm not even done with the content of the loop, but I did specify enough of the loop that I know that I should be exiting correctly if it is using the file correctly.
That second part of the conditional statement of the loop, aren't you supposed to be, if it passes, isn't it supposed to go to the beginning of the loop? Because you put the end again. Because if it's not equal to 10, you're comparing 10 CH, so if the 0 flag happens, shouldn't it be going into the loop? Because it's supposed to be equal.
On which line?
36.
On line 36? On line 36, it says, if I did read a line feed character, then get out of the loop, which is consistent with the meaning in C, because the meaning in C is stay in the loop as long as what I just read is not the line feed character. So that means if I did read a line feed character, it's time to get out of the loop.
Okay.
Okay. There are multiple ways to translate this. I mean, this is just one way to do it. And this is also consistent with the method that I taught early in the class. You invert the logic. In other words, you use the exit logic to say if blah, 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 go to the end of the loop, get out of the loop. So this is consistent with that approach. But some people like positive logic, so they check for the conjunction itself to branch into the body of the loop, and then if it doesn't branch into the body of the loop, they get out of the loop, which is kind of like one extra step, but it's still correct. Okay, so I'm going to test the program right now and say, just assemble the pilot file, parse.o, parse.s, and then ld parse.o. And I should probably give it some test files. Okay, I created one already, which is called EOF before end of line, and I'll just go ahead and create another one. Okay, we'll just call it simple test.txt. In this one, I just use 1, 2, but the editor will automatically append an end of line, so this one will behave slightly differently. Yep.
So in the example that you just gave of testing for the conditions into the loop, are they basically doing the same thing that you do testing for the negation, and they're just putting an extra needless line, or is there actually a condition to test into the loop instead of testing for the exit condition?
Well, let's take a look at the content of these two files, okay? Because I want everybody to see how they're different. This is simple test.txt. It contains the ASCII code of 1, the ASCII code of 2, and the line feed character. So this one will exit only because I read the line feed character. The other file that I just created earlier, which is called end of file before end of line, if you look at this file, it has the first 2 bytes being exactly the same. But this file, end of file before end of line, does not terminate the line with the line feed character. And that's how I can test whether your program is following the same logic or not. Okay. Any questions about this? Did I answer your question? Not exactly. Okay. Can you ask it again? I do want to answer the question.
Well, like so from the description that you gave, I got the impression that some people are testing, like in C, you'd use if the condition is true instead of if not true, exit.
Correct.
Right. So I was just wondering if they're setting up that kind of logic, are they just testing the if statement unnecessarily, and then they still have to test the negation to exit? Or
No, they would just if you test for the positive condition, if you keep the condition of the loop itself and then say if this condition is true, go into the body of the loop, otherwise exit the loop, it just has additional branches. You just end up with some extra conditional extra jump instructions that does not have to be there. But you can express it just as well. I mean it works too. And some people feel more comfortable with just sticking with the logic of the loop itself because they don't have to translate that in that case. And some people just want to follow the procedure, the mechanical procedure, which is the first thing is to negate it so that you specify the logic to get out of the loop. So either way works. This class is not about efficiency. It's just about can you understand how to translate that into assembly code, and either way is acceptable. Is that answering the question?
it is, yeah.
Okay, great. Yep, go ahead.
Just really quickly, if the read function reads whatever the character has into the ECX, would it be correctly to compare?
No. Nothing is
ECX?
being read into ECX. ECX specifies the address that will store the byte or bytes that you're reading in from the file. Okay? Okay, let's go ahead and run the program because nothing shows whether the program works, or how it works better than GDB. How many people did not use GDB at all with this program? So you guys are all becoming friends with GDB. Yeah,
It's impossible without it.
it's on a first name basis now, right? Well, that's the way it should be with all your programming classes, not just this one. Cout or printf, they're not flexible for debugging purposes. GDB is very flexible. If you don't like the command line interface of GDB, there are other ways to dress it up. I'm pretty sure who has used code blocks or dev C++. They use GDB in the back end. Okay, it's really GDB in the back end. They just dress it up so it's all kind of GUI like, but in the back end it's really just GDB. All right. So GDB stands for GNU Debugger.
I like his better.
Huh?
I like his better.
What is it?
Goddamn bugs.
Hey, that's job security there. Okay,
Right.
when you get out and become a developer, you will look at things very differently. It's like bugs are good.
That's right.
Especially when you know how to find them.
Yeah, you gotta write really bad code so only you can understand it.
This reminds me of Wally from Dilbert. Okay, I gotta digress. This because I know you guys are getting too serious. There was just absolute silence when I talk about this thing. So let's just relax a little bit and look at Wally and Dilbert. Write myself a minivan. I'm not sure whether it actually has that cartoon available still. No, that's not it. Oh, right there. Okay, our goal is to write bug-free software. I'll pay a $10 bonus for every bug you find and fix. Yahoo! We're rich! Yes! 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 I'm gonna write me a new minivan this afternoon. And then the boss, it just kind of dawned on him and go like, I hope this drives the right behavior. Yep. I like Dilbert. This one stood out particularly. Yep.
Is the minivan a program or what?
A minivan is a car.
No, I mean in that case, like I know what's minivan, but I thought like I'd write my new minivan, so I thought was it a program or what?
Okay, it's a language thing, you know. What Wally meant is, you know, he is going to intentionally put in so many bugs in the program that he would quote unquote find and fix those things. Because, you know, a minivan costs what, $24,000 or so these days. So you just need 2,400, you know, bugs to get a minivan. So he's going to intentionally write 2,400 bugs into the program. Then he will go ahead and find and fix those bugs. Okay, get a Chrysler, right? I mean, instead of a Honda, go get a Chrysler, but he'll get a minivan. So that's what he meant when he said, you know, he would write himself a new minivan.
I want to work for that company. I want to work for that company, build every bug I would fix.
Oh, there's another one. You know, how many people read Dilbert religiously?
Not religious.
Okay, there was one about the boss not knowing how to work a computer, so you know he doesn't know how to turn it off, I think, and then Dilbert said, you know, try this, shake it upside down. How do I clear the screen? And I'm 100% sure that someone, you know, actually implements that program for the iPad. It would be really hard pressed for a developer not to do it. Yeah, I mean, you know, the iPad has the accelerometer, so it can detect, you know, whether it's upside down or whether it's being shaken, right? So it would be pretty hard pressed for a, you know, programmer who has too much time on his or her time not to do it. I mean, this is like, you know, this is just a setup where, you know, it's a lure. You have to do it. You have to do it. You have to do it.
There has been in the history of my Apple phones and stuff. There's some of those shaking third screen options in there.
Well, they have programs, you know, you guys remember when you were kids, you know, they still do it now. They have these mazes, you know, made out of plastic, and there's a little ball bearing thing. You have to kind of roll it, you know, to go to a destination. They have those games for iPads, phones, and whatnot. So you can actually try to roll it, you know, to the destination. All right, so I think that's enough digression. You guys are freshened up a little bit already.
It's like a fresh shower.
Okay, so next thing is to test the program. Okay, you know, GDB parse, and what we want to do is to see whether, well, first of all, we want to see whether the program exits correctly. The second thing is, are we going to read the right kind of bytes and exit for the right reasons? So what we'll do is we'll put a breakpoint on. We'll put one breakpoint at while one end, you know, at the end label, and then we'll put another one into the body of the loop, which is on line 40. Okay, so you know, this way we can tell, you know, when are we staying in the loop and when are we getting out of the loop. So when we run the program, I would feed it a known test case. In other words, I'm not just going to type something, you know, to test the program. I'm going to give it a consistent test case every single time. Until it works for one test case, I'm not even going to move on to another test case. So we'll just give it simple for now, okay? Because simple is, you know, really simple. It should work. Okay. So this is our first iteration. It got into the loop. It's ready to go back again. But I'm not only interested in the fact that it is still in the loop. I want to see what is in CH. Did it actually read that character into the location that we call CH? Okay, and this is where also, you know, I have to kind of share some comments because of a conversation earlier. You can use print ch, but it's not going to give you the right result. Okay, print ch seems to give you the right result. Okay, 49 is actually 49 in decimal is 31 in hexadecimal, which is the ASCII code of the digit 1. So it is correct. Okay. But it's actually interpreting not only the byte as CH, but also the 3 bytes after CH. Okay, so that's why, you know, if you continue with this and you actually do something about X, this will change, and it's not going to look right anymore. The best way to do it is to use as much detail as possible. Yep.
So I ran into that issue, and I thought it was maybe actually using the byte after that, so I changed it to again. Did that count against us in creating?
It will not count against it, but I can comment on that approach. You're padding your CH long enough to get around this problem. Okay, which means it's not really fixing the problem. It's not fixing the root of the problem. It's fixing the symptom of the problem. Okay, there are many things, many times where you can just kind of pad things a little bit, and then the problem seems to go away. But it's not really fixing the core part or the reason why your program seems to be doing something wrong. So I'm not going to use that. I'm not going to count that against you. But I do want to make sure that you understand why the quote-unquote fix works. Okay, that which is the most important part is but why does it work? If I change .byte0 to .int0, suddenly everything is good again. All right. But the best way to do it is to use as much detail as possible. That means making use of the fact that that CH is supposed to only have 1 byte. The X command is always the most reliable one. You say 1 byte and I want to print it as a character. Interpret the actual ASCII code of that thing at location CH. Now it is always correct because it's only using 1 byte for printing. All right, so that's good. Let's continue the program. And we are in the loop again, because we won't be getting to the jump while one begin unless we're in the loop itself. So, do the same thing again. It should be reading the 2. Now this time I have to be careful because I know that in the next iteration, it's going to read the line feed character. So I want to make sure that it does, exit the program because of reading the line feed character. So I'm going to list the program a little bit. Yep, go ahead.
Why are you using reference in front of the character?
Because otherwise it will go to the location CH, grab those 4 bytes, and then interpret those 4 bytes as an address, and then try to dereference that address. We can try it. Okay.
Oh, yeah.
All right. So let's continue the program again, but this time I'm stopping at line 35. And it does not stop at line 35 because I want to make sure this program does exit because it is seeing a line feed character. Well, it's not too hard because the first thing I do is I'm going to look at CH again. Okay, CH does have the line feed character, ASCII code 10. And when I single step the compare instruction, it doesn't do anything. The compare instruction only sets up the flags to be interpreted by the conditional branch instruction, which is JZ here. But I can also look at E flags and see that the 0 flag is in fact a 1. So that means the JZ instruction should branch out. Single step, and it does. Okay? And if you feed it the other program, it will exit for a different reason. If you feed it the other test case, EOF before end of line, it would have exited right after the read operation and not even compare what it has quote unquote read because it really didn't read anything because it encountered end of file first. Are we doing okay so far with this portion of the program? Yep.
Okay, I don't understand what you just said. So if it exits because it reaches end of file and not end of line, then that's wrong?
It is correct. The C code does that as well. So your assembly version has to resemble the C code.
Okay, but you said the other one. Which one are you reading here?
This is simple, which has an end of line at the end of the line. Okay, we can run it again with the other one. So we'll go ahead and read from end of file before end of line. Okay, and just confirm everything. The first part will still be the same, and then the second one will still be okay because I'm reading 2 at this point. So I'll do a continue. No, I should not be doing continue because that's a single step. Okay, it should not get out. It did not, and now we're getting back to the beginning of the loop. And this time I need to stop at line 32. Okay, so we'll continue, and now we are at line 32. The question is, what is the value of EAX after the int instruction? Well, we can actually look at EAX. It has 0, which means the read operation did not read anything in because it's already at end of file. Now, if we single step through this program, it exits right away because we just compared EAX to 0. And after the comparison, it says if EAX is 0, go to the end of the while loop. And it just did that. So I know the behavior of the program is now correct.
Okay, so what if you didn't have that in there? What would happen?
You get some points deducted because
No,
that's
I mean, like in the program, what would happen?
in the program. What would happen? Well, you would have misinterpreted whatever is in CH as the next digit. In other words, in this particular case, instead of reading 1, 2 as the input, your program would have interpreted the input as 1, 2, 2, and probably get into an infinite loop because it would keep reading. It's looking for the end of file, which is, it's looking for the end of line character, which is never going to be there. So your program most likely would get thrown into an infinite loop and never really get out of the loop.
Okay, but you send it in the file. You
Yep.
try to read that. Like, okay, once you get to the end of whatever text file you have,
Yep.
what happens when you try to read?
The read, it is undefined. If once your read returns 0, any additional read from the same file descriptor, the behavior is actually undefined.
Okay.
So in some cases, it will break. It will just crash, which is good. In other cases, it will just keep reading nothing. It will just keep reading and saying, "I'm at end of file. Please get out of the loop." No, we're reading again. So it depends. Now, to really understand that behavior, one way to do it is to use man to read, and look for the word EOF or end of file. Okay. Just trying to. Okay. 0 indicates end of file, and the file position is advanced by this number if it is successful. It is not an error if this number is smaller than the number of bytes requested. This may happen, for example, because fewer bytes are actually available right now. Maybe because we are close to end of file, or because we are reading from a pipe or from a terminal, or because read was interrupted by a signal. So it does not really behave, it doesn't explain what happens if you try to read repeatedly, even though read is returning 0. Now it seems like we are not talking about the assembly programming concept, but remember, in the class, I did describe the read call to be identical to system surface number 3. So this document actually applies to system surface number 3.
Okay, so let's say that on your machine, when you run the scripts or whatever, if you don't have that jump in there.
Let's find out.
Wait. If you don't have the jump in there, it still exits the loop, okay?
I don't think it will exit the loop because it doesn't.
Let's just say it did. So if it did that, then we shouldn't get any deductions, right? Because it does follow the spirit of the code.
You can explain that to your boss.
Spirit of the code.
Spirit of the code. Yeah, that's a good one. I'll put it into my book of quotable quotes. Okay, but I am curious to find out what it's going to do. So what I can do here is I will just go ahead and now this is something okay. So to do remove the comments just for testing. Because I already make sure my program is working up to this point, so if I do something like this to test the program, I have to remind myself to undo that. This is also a good time for those of you who use a revision control program or setup. This would be a good time to check in the program because you just verify that your program is working up to a certain point. Time to check in before you even specify the content in the loop. Just in case putting that in changes the behavior of the code, at least you know that, oh, but it was working before I put that in. So maybe I put in something that I put in changed the behavior of the loop itself. All right, so we're gonna do reassemble, relink, and GDB the file. And I'm pretty sure it's not gonna get out of the loop.